If you have a data set that is normally distributed, we know that if we look at the curve of the data set, if we wanted to find out the probability or proportion of values that fall within a particular region, so let's say, for instance, on this little sketch I'm making, I've sketched a normal curve, and let's say I want to find out the values that fall at this value or less than it. Finding the probability that a value falls in that region is the same thing as finding the area under this normal curve. So then that leads naturally to the question, well, how do I find that area? Now, one of the ways that we can do this involves a technique called standardizing the variable. So suppose that data value, again, comes from a data set that's normally distributed, and that data set has mean mu and standard deviation sigma. Then we can create a new value that is computed by taking the data value, and I'll call that x. I subtract off the mean mu, and I divide that difference by the standard deviation sigma. And the number that's generated from that is called a z-score. So I can create this new value from any of my original data values by doing this computation. If I collect all of these new values, it will also be normally distributed. And for that new data set that I've just created, which has a bunch of z-scores, that new data set will have mean 0 and standard deviation 1. And we call this new distribution that has all of these z-scores in it, it's called the standard normal distribution. And this distribution is helpful for a variety of reasons, but one of the things that we can use for this distribution is because since I can do this with any data set, is I can take the data value, subtract off the mean, and divide it by the standard deviation, and I get this z-score. We can create these tables of for various z-scores what the area under the curve would be with respect to that z-score. So I have a table right here. I'm going to call this table A. And in this table, what this table is going to tell me is if I have a given z-score, it's going to tell me what the area is under the curve to the left of that z-score. Now that is very, very special. When I'm given a particular z-score, this table of values that I'm going to be looking at is going to tell me what the area is under the normal curve to the left of that value. So I can then use these tables to find areas for certain data values. So let's work through a couple of examples. So remember, our goal is I'm going to be given, for these ones, we're just going to start by working with z-scores, and given a z-score, I want to find the area under the curve that satisfies certain conditions, and I'm going to use table A to find that area. So our first example is going to ask us to determine the area under the standard normal curve that lies to the left of z is equal to negative 1.99. When solving these problems about the normal distributions and finding areas under the curves and things like that, I always like to create a sketch of what's going on with appropriate shading and labeling, so that way I can have a good visual reference of what is happening in this problem. Alright, so I'm working under the standard normal curve. Alright, so I'm going to draw my horizontal axis here, and I'm just going to sketch a normal curve. Because I'm dealing with the standard normal curve, the mean, which needs to live smack dab in the center of this curve, is 0. And I'm not going to put down any standard deviation markers, but I'm just going to remind myself on this curve the standard deviation is 1 by putting it right underneath my mean label. Now down here along this axis, these are all my z-scores. And right now I have a z-score of 0 that's already marked. For this particular problem, I'm given a z-score of negative 1.99. Now this doesn't need to be perfectly placed, but a z-score of negative 1.99 is going to be over here to the left of 0. So I'm just going to kind of guesstimate where I think that's going to be, So I'm just going to put a mark somewhere to the left of 0 and label it 1.99. So there's my z-score. Now specifically for that z-score, I want to find the area under the curve that lies to the left of it. So what I'm going to do is from my mark, I'm going to draw a line up until I hit my normal curve, and then I'm going to shade to the area to the left of it. So I'm just going to go ahead and shade that area. And that is the area that I now want to find. So I want you to notice that you're given a z-score, and with respect to that z-score, we want to find the area to the left. And that's what table A will tell us. Let's talk about how to use table A. Now keep in mind my z-score is negative 1.99. Now we're going to have two tables here. One with a label of values when the z-score is negative, and then I have down here the areas when my z-scores are positive. So I'm working with negative 1.99, so I'm going to stay up over here on my negative table. And over here on my left-hand column are going to be kind of the first part of my z-score. So I'm looking for negative 1.9, which is going to be right here. And then I want to finish it with a 9. Now if you look up here, let me zoom out. If you look up here at the top of this table, okay, this is going to be what would be in the 100th spot for the z-score I'm working with, is what's going to be up here. So I'm looking at negative 1.99, so I already have negative 1.9, and then here's going to be the other 9 right here. Okay, so I'm going to be going across this row and then down this column in order to complete my negative 1.99 z-score value, and ultimately then the area that's going to be the left of that value is 0.0233. So I'm going to go ahead and record that in my work. This area that we just found right here, this area is 0.0233. And we got that from using our table. Now let's try this again, but what if, on the next example, I change up, I don't want you to find the area to the left, I want you to find the area to the right. So on the next problem it says determine the area under the standard normal curve that lies to the right of z is equal to 2.23. So again, sketches are very helpful. So I'm just going to sketch a normal curve. I'm going to label my mean 0, and I record my standard deviation as being 1 right underneath that. The mean is what the kind of the important value is, because when I go to place my z-score, I need to know am I going to place it to the left or the right of my mean. In this case, since I'm looking at 2.23, which is going to be positive with respect to 0, I'm going to place it somewhere over here to the right. Okay, so somewhere over here to the right, I'm going to put 2.23 as being my z-score. I'm going to come up until I hit my normal curve, and then I'm going to shade the area to the right of it. Now this is the area that I want to find. We're going to come over here to table A. And since 2.23 is positive, we will come down to where we have those positive z-score values. So I'm looking at 2.23. So over here in this left-hand column, I'm going to come down until I get to 2.2, which is right here. And so I would be working across this row, but I need to finish the value. So it was 2.23, right? So there's where the last spot would end with a 3. So then when I come down, this is the value that I want, the 0.9871. Now keep in mind though that that is going to be the area under the curve to the left of 2.23. So the area to the left of 2.23 is 0.9871. If we come back to my picture, what we just found is we just found the area to the left, so this area under the normal curve to the left of 2.23 is 0.9871. Alright, but that's not the area that we wanted, right? We wanted the area that would be to the right of 2.23. So here's where we need to keep in mind that the total area under the curve is 100% in its percent form or written as a decimal value, it's just 1. And right now when we go to that table, it's always giving us our areas as a decimal value that we could convert to a percent if we wanted to. So if the total area under the curve is 1, and I know then the 0.9871 is the area that I don't want, because that's going to be the area to the left, then to find the area to the right, it's going to be 1 minus 0.9871. My total, take away what I don't want, will leave me what's left. So 1 minus 0.9871 is 0.0129. So that's this area. That would be the area to the right. So far we've done a problem where we're looking for the area to the left, and then we just now looked at one where we're finding the area to the right. Let's do one where we have to find the area in the center. So for the next one, it says determine the area under the standard normal curve that lies between z is equal to negative 3.03 and z is equal to 1.98. So again, to start, I'm going to sketch a standard normal curve so I can kind of see what's going on here. For the standard normal curve, its mean is 0 and its standard deviation is 1. So one of the z-scores they gave me is negative 3.03. So that's going to be to the left of 0. And that one's a little over 3 standard deviations away. So that's going to be kind of far away from 0, almost all the way out here in kind of these tiny tails. So negative 3.03 is going to be out here. The other value they gave me was a z-score of 1.98. Since it's positive, it's going to be to the right of 0. And that's about 2 standard deviations away. So let's put a marker there, 1.98. I want to find the area under the standard normal curve between these two values. So between these two values, let's go ahead and shade that region. That's the area that I want to find. Now remember, our table is only going to give us the area under the curve to the left of a value. So here's what's going to be our game plan. If I can use the table to find the area under the curve to the left of 1.98, it would give me all of this area that I want, but it also gives me this area out here and the left-hand region and that tail that I don't want. So we're going to use our table to find the area under the curve from 1.98 all the way to the left. And then I'm going to subtract off the area that would be right here that I actually don't want to include. That's not part of the area that I want to find. Right, so we're actually going to need to find 2 different values where I get the area to the left, and we're going to subtract those 2 values. All right, so that's our game plan. So let's actually start getting those numbers so you can kind of see what's going to go on here. So first off, we're going to find the area under the curve. All right, so let's maybe write this down. Let's find the area under curve to the left of the 1.98. So let's come over here to our table. I'm going to erase some of my marking. So I've got 1.98. So here's 1.9. So I'd be looking across that row. Coming up here, here's the 8. So I'm going to be coming down that column. So this is the value I want, 0.9761. So the area under the curve to the left of 1.98 is 0.9761. So the next thing that we're going to do with that number is we're going to subtract off the area under the curve that's to the left of negative 3.03. And again, the reason why we're going to do that is this 0.9761 that I just found is the area to the left of the 1.98, which includes all of the region that I want, but it also includes this region out here in the tail that I don't want. So the game plan now is we're going to find out how big this area is out there in that left tail in the region that I don't want, and we are going to subtract that area out. Right, So let's go figure out how much area there is over there. Using our table, our value is negative 3.03, so let's go back to our table. Negative 3.03. All right, so negative 3.0 is right here, so I'd be looking across that row. I want it to end in 3, which is that number up there, so I'm going to come down. So the area under the curve to the left of negative 3.03 is 0.0012. So 0.0012. So that's going to be the value that I want to subtract off of that other area that I found. And when I subtract those values, we end up with an area of 0.9749. All right, very good. So let's take a look at one more example. This one's going to be a little bit different. This one is determine the total area under the standard normal curve that lies to the left of z is equal to 1.68 or to the right of z is equal to 3.05. So if I sketch again for myself a standard normal curve, it has a mean of 0 and a standard deviation of 1. And I'm going to go put down the markers for the values that are under consideration. So I have negative 1.68, so the negative is going to be to the left of 0. Alright, so I put down a marker for negative 1.68. And with respect to that value, I want to be to the left of it. So I'm going to shade the region under my standard normal curve to the left of it. But it says, or I want the area to the right of 3.05. And if I'm in one region or the other region, I would want to include both regions. So one or the other is okay. So 3.05 is going to be 3 standard deviations away to the right, so that's going to be kind of all the way out here in the little tail region. So that would be 3.05, and I want to find the area to the right of it. So the kind of this area out here. Now again, I want both of these areas. So this is not like, we're going to break this up into 2 separate parts, but ultimately I want to find what that combined area is of everything that I have shaded. All right, so our game plan then is we're going to first find this guy's area. So the area that is to the left of negative 1.68. Our table is beautiful to give us area to the left. So negative 1.68, we come back over to our table. Negative 1.6 is right here. I find 8 up here. Come across the row and down the column. So the area to the left of negative 1.68 is 0.0465. Let's go ahead and record that. 0.0465. Now that's just the area over here in this left region. Let's also find the area over here in this right region. Now if you go back up to the previous problem where we had to find the area to the right, remember how we did that is because our table can only give us area to the left, and I know the area under the whole thing is 1. To find this area to the right, it's going to be 1 minus whatever this area is over here to the left. So let's use our table to find what is the area to the left of 3.05. So that value is positive. So I'll come over here to my positive values. I want 3.05. So here's 3.0. And then I want to grab 5 up here. And then come down that column. All right, so where the 2 intersect is 0.9989. So 0.9989. And that value should make sense. With respect to this value, the area to the left of it is almost going to be the area under the whole entire thing, right? So in order to find the area to the right, in that little tiny tail region, we're going to do 1 minus that value, and we're going to get 0.0011. So this total area that I want, we're going to add up those two values. So 0.0465 plus 0.0011 will give me an overall total area of